you filthy swine! Get in here, have a seat, sit on those trotters and listen. There's an interesting unconventional physicist called Sabine Hossenfelder, a German lady who seems to get a lot of flack for criticizing other mainstream physicists. If I'm being told that a more mainstream idea is the only idea that should be presented and all others are wacky, then I tend to think that that's perhaps a red herring, maybe. But anyway, there's an interesting idea about the universe of a physics model called the block universe, which suggests, as far as I'm aware, and we're going to read into this now, that everything that could happen or will happen already has happened, and the universe itself is just a static block. Everything that exists eternally. And how does that actually work? How can you actually conceptualize such a universe? What does that mean for time and perception? This article on Sabine's own blog site, written by herself, The Block Universe, by the lady Sabine. I was just about to throw away Tov's paper, Is There an Alternative to the Block Universe View, when I realized I totally forgot to let you know my conclusions about it. Well, let's see, maybe she agrees, maybe she doesn't. In my earlier post, every now and then, I explained why I think the most plausible explanation for our perception of the now being different from the past and the future is due to the ability of our brains to store memory. I thus believe in the block universe in which there is nothing special about the now, and the past and the future exist in the same way as the present moment. From my own personal narrow-minded perspective, this makes sense to me. Things in the past existed, I know they did. Things in the future continually exist because I'm experiencing them now, as are you. Anyway, nevertheless, I want to point out this isn't more than a belief of mine that I personally find plausible. Especially, I do not think it follows from special relativity, as some comments indicated, and also Petkov argues in his paper. Here, I want to explain why I don't think his argument holds. I will pick around on Pektov's paper not because I dislike it so much, but because it is actually a useful summary that also contains a brief historical introduction to the previous work on the issue. Most notably, the Rajik-Putnam argument, which I don't know anything about. Please note that the following does not take into account quantum mechanics, with which everything becomes much more complicated. Preliminaries. The following should be familiar to everyone who has opened a textbook on special relativity. So excuse me for being somewhat brief with the basics. In special relativity, one can construct the surface of simultaneity of an inertial observer, Bob, in a straightforward way. One puts two lights in equal distances into the rest frame of the observer, meaning their relative velocities vanishes. If Bob measures signals from both lights to arrive at his world line at the same time, he says they were emitted simultaneously. Doing this for lights of all possible distances creates a surface called the surface of simultaneity, on which all events lie that happen at the same time according to Bob. One can repeat this for all instances on the world line of the observer, which gives a slicing of simultaneity. For the observer in rest, these are just parallels to the x-axis in Minkowski's space. Now, I've seen this concept before, but described with a graph. So it's a bit difficult, not being an expert on this, to actually explain this. I think that the problem that is being described here is how do you measure the idea of now when all objects are in motion and their times are running differently based upon their speed relative to each other. So the concept of now becomes very difficult to pinpoint because it only really works subjectively. And observing events from two different sources that are moving at two different speeds relative to you can give you results of very different nows for those two different events that you're observing. If one considers a second observer, Alice, moving with a relative velocity to Bob, she can do the same construction. It turns out, however, her notion of simultaneity is a different one, and her slices of equal time are not identical to those of Bob. The reason to this is that the speed of light is constant in special relativity and the same for all observers. If Alice and Bob's world lines cross at one point, the events they consider simultaneous with this meeting are two different lines that form an X. This is illustrated very nicely in this figure from the wiki comments. Oh no, let's go see. There we go. This makes all sense now. We all know what's going on now, don't we? Look at this. I think we've got multiple graph lines intersecting. We've got green, we've got blue, and we've got red. The relativity of simultaneity. Are these meant to be two different observers moving at different speeds? The point that is being got at here is that there is no such thing as now. There is only your now. And other people's nows are not in line with your now. There isn't somebody, some cosmic being banging on a drum every second and everything is stepping forward in synchrony across the entire universe. It's more the fact that things are moving, their clocks are moving at different speeds relative to each other based upon their motion and relativity. That's the way I see it, if that makes sense to anyone else. Here, event B is simultaneous with event A in the green reference frame, but it occurred before in the blue frame and will occur later in the red frame. Blue and red. Green? What? Oh, I see. These arrows are pointing there. It occurred before in the blue frame and after in the red. So what we don't get from this image is the motion of these objects. I don't know. Let's move on. Let's keep reading. The argument then goes as follows. If everything exists that Bob calls simultaneous, but there is nothing special about Bob, then everything that Alice calls simultaneous exists the same way. You can repeat this for all observers that cross either of these already existing surfaces anywhere, and you'll fill up the whole space. Thus, everything in the four-dimensional plane exists because everything lies on somebody's surface of simultaneity. So the effective point there is if this becomes more pronounced when you're looking at objects that are far away, that are moving at very fast relative speeds. So this isn't something that you'd be able to perceive or track locally so easily. But let's say there is an object far away over there that's moving very fast in one direction, another object in another direction that's moving very fast. You're seeing their light simultaneously, but the light emitted from those two objects will have originated at different times, and because of the different relative speeds, the point at which the light that you see was emanated varies potentially greatly. So neither of those two objects are necessarily experiencing the same now, if you see what I mean. There was a criticism of this argument by Stein, which I didn't read, so I can only tell you what Petkov says about it. Apparently, Stein's criticism is that the notion of present but distant events does not make sense, since one cannot say anything about the now that is not also here. It's funny how we try our hardest to describe these very abstract concepts with a very limited character set and language. So one should talk only about the here, now. Exactly. If you're trying to measure the simultaneity of two objects that are super far away from each other and you cannot say how simultaneous their time is relative to you. To reformulate this into B speech, what does that mean? I'd say the argument is you can't have information about the existence of anything that is not yet causally connected to you, like everything on your space-like slice is. Thus, concluding it exists just because you measure it later is not possible. This is probably a very fanciful interpretation of mine about a paper I didn't read. Apologies, as Sabine claims. Petkov wants to know that number one, the universe view in which the universe is regarded as a timelessly existing four-dimensional world is the only one that is consistent with special relativity. From what I've heard, that's not true. Number two, special relativity alone can resolve the debate on whether the world is three-dimensional or four-dimensional. I will in the following argue that one is wrong and two is correct. What did two say? Special relativity alone can resolve the debate on whether the world is three-dimensional. Okay, yes, special. She's placing a lot of emphasis on special relativity because it's extra special. For being able to conclude anything at all, I will start with explaining what I am talking about. There is a possibility I am not using the terms as your philosopher next door does, but at least you know what I am talking about. A. The block universe is a 3+1 dimensional space-time with a Lorentzian signature in which there is no present moment that is special in some regard. B. Presentism means there is a notion of now, and it is only the now that exists. This can be further subdivided into categories. B1, presentism in which time is a parameter. B2, presentism in which time is not a parameter. For maximal carefulness, I want to point out that another assumption which also goes into the argument is Time is either a parameter or a dimension, and there is no other possibility. Interesting. See, I see time as a series of moments strung together. And there are all sorts of moments in the universe that you will never be able to observe because you have branched into a different relative observable space. Looking at the double slit experiment and seeing how events can diverge into multiple conclusions, it suggests to me that there are multiple observers to match each of those outcomes. So if there are multiple observers, then you will see all outcomes, but you won't be able to tell your other observer selves of those outcomes. That's one way I'm trying to interpret that, but let's move on. If that wasn't the case, one could never make a claim like, is the only option consistent with as done in one? To call upon the principle of finite imagination, one should, however, keep in mind that this is an unproved assumption and that an alternative option can't be outruled. I will understand special relativity as the relativity of all observations in all inertial frames. Sorry for nitpicking, but I want to throw out all merely philosophical baggage that isn't observable. You'll see why later. In media res, for the reader who has taken a class in special relativity, the rest of the argument is now actually trivial. Let's start with claim 2. We know that time can't be a universal parameter because we have experimental proof the passage of time depends upon the state of motion and the path of an object. Thus, presentism B2 is falsified, which means with A, time is a dimension. It follows 2 is correct. Okay? Now, to claim 1, the first observation is that one should be skeptical about this claim because it involves the notion of existence, which doesn't appear in special relativity altogether. So how can one possibly say whether some sort of existence is compatible with special relativity? Well, the interesting thing about this whole thing is that we're talking about observers. We're talking about perception. We're talking about subjectivity, perception, and the difference between your experience and another individual's experience, and how the time is completely different for both of you. As she said earlier on, you can only rely on now if it's here and now. She says, I'll give you an analogy. I could ask you whether my invisible friend is compatible with complex analysis. What's going on here? Complex analysis, traditionally known as the theory of functions of a complex variable, is the branch of mathematical analysis that investigates functions of a complex variable of complex numbers. It is helpful in many branches of mathematics, including real analysis, algebraic geometry. All right. Study of holomorphic functions. Math. That's what it is. At the very best, you could say the question doesn't make sense, or to make it sound somewhat more sophisticated, it is ill-defined. Unless I tell you something about my invisible friend, there is nothing incompatible because in complex analysis there are no invisible friends. If I now told you my invisible friend is an entire function that is bounded but not constant, you could go and prove this is incompatible with complex analysis via Louisville's theorem. Well, I don't know anything about that. So how can Petkovs, as Reitjik and Putnam, can and do say anything about claim 1? Well, the reason is that they don't actually explain anything about existence. Instead, they say the now does exist, thereby exporting existence into a concept that can be defined in special relativity. See, this is an interesting thing when you remove the observer from systems that require observation to make sense. If you make everything objective and nothing subjective, well, you're leaving out our personal subjective experience from the entire equation, which is kind of wacky, really. Since I do not want to define existence either, I too want to export it into the now. This then, however, doesn't allow us to solve the problem addressed in 1, for there is no reason why the existence should be bound in the now in the way one can define it in special relativity. Let's make that more precise. The now in special relativity can be constructed using surfaces of simultaneity in the usual way as mentioned in the preliminaries. This is a definition of now. It doesn't say anything about existence. If you, however, use this definition of now and say what is now according to this definition exists, then you suddenly have a definition for existence. Cool, eh? However, this is a definition and not a conclusion, as you can't say anything about whether something exists on your surface of simultaneity elsewhere. You can only say something exists if it is not only now, but also here. Okay, right? Because two observers might be observing two objects at different points. in their time. So the flaw in the argument is that you can very well have a notion of now that exists that is not in disagreement with any measurements confirming special relativity, because there is no reason to define presently existing with the surfaces of simultaneity in special relativity. In fact, everything that can be said about existence in special relativity is a completely empty statement, right? So there's no mention of perception or our conscious existence in special relativity at all. It avoids all of that baggage of what is your perception of now. To see this, put an existence slicing with a time parameter t on Minkowski's space and say for each t it is only the respective slice that exists or is now according to this definition of now. This can't be in conflict with experiment, for you never measure existence anywhere than where you are. It's very true. Yeah. What you measure are signals from elsewhere and or elsewhen. Yet the further out you look, the further elsewhen you're looking as well. Yet on which now slice these signals sat with you at emission is completely irrelevant. All that matters is that the propagation takes place according to the laws of special relativity, because that's what we have measured. This is not a block universe because it has a notion of a present moment, but it is not a disagreement with any predictions of special relativity. Thus, one is wrong. Anyway, there is, however, two more things to be said here. One is that this option is compatible with all our measurements, but it does, of course, break observer independence as a matter of principle. For singling out some slicing means singling out preferred rest frames. The other one is that this option is compatible with special relativity and all measurements because it doesn't have any observables whatsoever and is not falsifiable. To make this an interesting scenario, you'd have to tie some observables to the existence slicing. Well done, Sabine. Although, kind of tricky to fathom. Here we go. Maybe this one will explain it a little bit easier. We'll see. This article on abc.net.au, that's in Australia, don't you know? The block universe theory, where time travel is possible but time passing is an illusion. Written by Dr. Christy Miller for Catalyst. Right. I think this article is a bit more layman. We'll see. Your birth is out there in space-time. Your death, too, is in space-time. Every moment of your life is out there, somewhere in space-time. So says the block universe model of our world. According to the block universe theory, the universe is a giant block of all things that have ever happened at any time and at any place. On this view, the past, present, and future all exist and are equally real. Well, how can this be? The block has 4 dimensions, 3 spatial dimensions, say length, height, and width, plus a 4th temporal dimension, our time. Well, let's make it easier by visualizing the block model of our world as a 3-dimensional rectangle, or cuboid. 2 of that cuboid's dimensions, let's say height and width, represent 2 of the universe's 3 spatial dimensions. The 3rd spatial dimension in the above diagram is left out, the length of the cuboid, and replace it with time. And one end of the cuboid is the Big Bang, and the other is the very last moment of the universe. Maybe it's a big crunch. The cuboid is filled with every event that ever happens. Where these events are in the cuboid represents their location in space-time. All events, including your birth and death, and this very moment as you read these words, exist somewhere in the block. In the block universe, time doesn't pass. It often seems as though where we are today is present and yesterday is past and tomorrow is future. It also seems the present moment changes too. After all, tomorrow, it will seem as though tomorrow is present and yesterday it appeared yesterday was present. So from our perspective, it appears that time flows or passes. But in the block universe model, time doesn't flow. In other words, in a block universe, there is no specific present moment, and past and future moments are relative. Think about the idea of here. I am here. You, while reading this, can truly say, I am here, even though your here is different to mine. On the block universe model, talk about the present or now works just like talk of here. Remember last week when you said to your friend he was late arriving for coffee, now you're here, or when, long ago, Caesar said, I'm now crossing the Rubicon. These claims are both true. That's because all it means to talk about the present or now is to talk about the place in time where you happen to be. Since we are always located wherever we are, that's trivially true, everyone is located in the present, just as everyone is located in the place they call here. According to the block universe view, time or temporal relations of earlier than or later than exist. These relations hold regardless of where anyone is located. So suppose Bert the dinosaur is located earlier than Sally the dog. That relation between Bert and Sally holds, regardless of whether we are located earlier than Bert or later than Sally. Bearing this in mind, it is possible to see how to make sense of the idea of past and future. Just as on this model now picks out whatever time I happen to be located at, past picks out any time or events at those times that are earlier than my location, and future picks out any times or events that are later than my location. Does that mean we can travel in time? Maybe. We're always traveling forward, are we not? If time is just another dimension, a lot like the spatial dimensions, does that mean we can travel in time? The short answer is yes. Of course, things are way more complicated than that. Traveling in time is clearly much more difficult than traveling in space. It might be very technologically costly to time travel, so perhaps it's not really something that, practically speaking, we can do. But it's certainly possible. We already know that traveling very fast will result in time dilation, so we know it's possible to travel into the future just by traveling very fast. We can travel quite a way into the future if we can travel at some reasonable percentage of the speed of light. We also know how to travel into the past. We can use that by using wormholes, which are shortcuts through space-time. Okay, but I don't think that has actually been observed. They've been theorized. I don't think there has ever been discovery of a wormhole. So that's a bit of a leap there. Not that I'm saying they don't exist, but, show me things that are measurable. So if I can travel in time, can I change the past? No, that would create a contradiction, and there are no contradictions. Remember, on the block universe model, the past is no different than the future or the present. Everything is relative. What is past to you will be future to someone else. So if I travel back to the past, I'm traveling to what is someone else's future. That means the past won't be any different in kind to the present. What will happen if I travel to the past? I'll get out of my time machine and start walking around. I'll breathe the air and chat to people. What point are you trying to make here? Obviously, this will have effects on time travel too. I'll tread on ants. I'll talk to people from that time. I'll pat horses. I'll feed donkeys and so on. I'll act in the past in the sorts of ways I act in the present. But I won't be changing the past. Just as when I eat cornflakes instead of toast tomorrow, I am not changing the future. I'm just making the future the way it is. When I travel to the past, I don't change it, I just make it the way it is, and always has been. Confused yet? Let's recap. What I do tomorrow makes tomorrow the way it is, the way it always has been. What I do in the past makes the past time the way it is, it always has been. If I travel to the past, I'm part of the past. Importantly, I was always part of the past. The events in the block are there for all time, they do not change. So as a time traveler, it's not as though I suddenly appear at a past time. It's always been the case that I am located in that past time. Nothing a time traveler does changes anything in the block. Instead, what the traveler does at any time makes that time and later times the way they are. That means that we know that some things we attempt to do in the past fail. We know that Hitler rose to power in the 30s, so we know that if our time-traveling future selves try to prevent this from happening, they fail. But that doesn't show that our time-traveling selves don't succeed in doing lots of things in the past. For all we know, the reason the past is the way it is in part due to the presence of time travelers. What's interesting, though, about all these descriptions of the block universe is the constriction of 3 dimensions of space and 1 dimension of time. Now, if you had multi-dimensional time, which I think the double slit experiment suggests that multiple effects occur from every cause, then would you not have a multi-dimensional block? So you would have more than just 1 dimension of time. You'd have a hyperdimensional block where all things that could possibly occur have occurred. So there's a location in the block for every single potential that could occur. So you could go back in time and kill Hitler, and you would just find yourself on a different relative path where Hitler was assassinated during that period. So I don't know. I don't necessarily agree with this. A lot of the evidence I've seen with quantum physics suggests that there are multiple effects to singular causes. And to me, that suggests that there are multiple observers to observe those multiple effects, and that there is a divergence of perception along those paths. So there are multiple versions of you observing multiple things. We have a very ingrained bias for our own importance, and we've seen this being eroded over time, when you had was it geocentrism, where people thought the Earth was the center of the universe, and then the sun was the center of the universe, and relativity has become more and more of a buzzword, but also an important, in my mind, rule to try and apply to everything. And just because you have a linear series of events that you remember doesn't mean that is the only series of events that could have occurred, or could perhaps have occurred if a multi-dimensional block like this were to exist. Like if you look at the path that light travels, light generally travels in straight lines, and your memory of events is effectively a straight line. You remember a certain series of events, and if those events had diverged in any way, you could make a comparison with light being reflected and sent in other directions, but the light itself would say it's just traveled along a straight path. So my query here, and I don't have any direct evidence, is if every possible event has occurred, even if we're just assuming there's only 3 dimensions of space and 1 of time, what is perception? If all events have occurred, how does your perception of time factor in to the fact that you're suggesting the universe is eternal and everything that could possibly happen has already happened? Because you're not experiencing everything at once, you're experiencing one thing after the other. So what is perception? It is an interesting question. I think perception is, if you're familiar with programming and linked lists, where each node in a list has the address of the previous node and the next node, perception, I would argue, is similar to that, where you remember acutely how things were just a moment before, and you have ingrained instinct on how things will transpire. So the arrow of time is a bias held within your mind for what has happened and what will probably happen next. So you have cognitively a direction, an arrow that your perception of time is following, which is one moment pointing to the next moment. And those next moments also point backwards to the current moment. So it's kind of like, in this sense, perception of now is just a slice or a node within a whole load of potential directions of the next now. It's hard to explain, but it's interesting. The idea that the universe is eternal and that everything that could possibly occur already has. Everything that has or will happen already does, which is hard to wrap your head around because it's not really in line with our day-to-day experience. Make sure you like this stream. It's helpful. It's encouraging. I like it. Please like me. If you don't like me, that's fine. But anyway, that is it for now. I have nothing else to say except Pigwig out.
Oink, oinkity, snort, snuffle, snuffle, squee, oink, oink, wee, squeal, snort, snort, oinkity, squee. Oink, oink, oinkity, squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinkity, oink, snort, snort, squee, oink, 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 wee, 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 oh. Snort, snuffle, oink, squee, squeal, wee, snort, oinkity, oinkity, oink, oink, snuffle, wee, squee, snort, oink, squeal. Oink, oink, oinkity, squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinkity, oink, snort, snort, squee, oink, 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 wee, 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 oh. Oink, oinkity, snort, snuffle, snuffle, squee, oinkity, oink, oink, snuffle, wee, squee, snort, oink, squeal. Oink, oink, oinkity, squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinkity, oink, snort, snort, squee, oink, 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 wee, 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 oh. Squeal, squeal. Snort, shuffle, oink, re-squeal, re-snort, oinky, oinkity, oink, 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 snuffle, re-squeeze, snort, oink, squeal, oink, oink, oinkity, squee, squee, re, snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 re, oh. Squeal, squeal, snort, snuffle, oink,